So I'll start by sharing first an image of my setup, just to refresh people's memory if you're on this morning, or maybe for the first time if you're just joining us. So this is my telescope in my backyard. I live in the center of Ottawa, and this is sort of my permanent setup. So it's a concrete pier. I'll zoom in a little bit here. Is it sharing? Oh, it says my share is paused. Not sure why it said my share was paused. Let me go.
Jim, we were seeing your screen and not your face. You're back to now not sharing your screen.
Yeah, it was giving me an error saying that my pause was my share was paused. So I'm gonna go try it again. There, can you see the telescope?
Yes, we can.
Zoomed in, okay. So I have a concrete pier. It's about 5 feet in the ground. The mount is an equatorial style mount, if you remember from the presentation earlier this afternoon. And on it, I have 3 telescopes at the moment. I have 2 refractors, a 2.5 inch, a 4 inch, and then I have a 10-inch diameter Ritchie-Chrétien telescope. And that is the telescope that I use for my lunar observing. I have another view here of what the camera looks like on the back. It's a similar setup to what I showed earlier this morning. So it's a monochrome camera made by ZWO. It's a Chinese company, and it's especially designed for planetary and lunar imaging. So the image we'll be looking at today is this one. So this is actually a mosaic of images that I put together from data I collected a month ago. So this is roughly what the moon looks like today. I think it's more like what it was yesterday, but pretty close to what it would look like today if it wasn't cloudy out. And I collected the data and combined the images together to make this single portrait of the moon. And if we zoom in, we can get some more detail. So the reason that we choose, well, we didn't choose it, but the reason why Astronomy Day is on this particular day has to do with the phase of the moon. It just happens that the first quarter phase of the moon is conveniently located in the sky and at a convenient time of day for people to observe it. If it wasn't cloudy, you could go outside right now and see it already fairly high in the eastern sky. And it's in the sky pretty much all afternoon and into the evening. So that's why we have this event this particular day of the month in the springtime. And the first quarter moon is quite an interesting time to observe the moon because the angle of the sun highlights a lot of very interesting features. And you can see here, if you were here for Simon's talk about planets and moons, he would have talked about these mare, these dark patches that you can see on the moon that are actually impact craters that have since filled with lava. Lava has bubbled up through the floors of the craters and has flooded them to the point where we no longer see it as an impression. We just see it as a relatively smooth, flat surface. And we know that these mare are younger than the brighter parts of the moon because of the number and the size of the craters that they have. So let me zoom in a little bit and you can see what I mean. if we look at, say, this area over here, so the area on the right side here, which is brighter, lighter in tone, has many more craters showing, and craters of many various sizes. That is in contrast to in the Mare, where we see very few craters, and the craters we do see are much smaller than in the other area. And this has to do with how old these two areas are. So the area on the right is much older than the area on the left, and so has had both more time to accumulate craters, but also it was old enough that it was around at a time when there were more things whizzing around our solar system to impact into the moon. So back it back out here. Some of the other things that really are highlighted by the angle of the sun are the features that are along what we call the Terminator. So that's the edge of the shadow between dark and light of the moon. So the sun is currently shining in this direction, off to the moon's right. And as you get closer to the side of the moon, we get light coming at steeper and steeper angle to the surface. And as a result, it really highlights the topography of the moon's surface, so that the physical height of these features is highlighted as we get closer to the Terminator. So for example, if you look at this mountain range, we can see, because of the angle of the sun's light, that they have a real physical height. These particular mountains are on the order of a couple of kilometers tall, and we can see that in the shadows. In fact, there was a period of time, I think it was sort of in the 1800s, I can't remember exactly when, but there was a field of study of the moon where people would, knowing the position of the sun, they would measure the length of these shadows, and they would use trigonometry to figure out how tall these features actually were. And they used that to map out all of the moon's surface and figure out how deep craters were and how tall the mountains were. It was pretty clever, because the numbers that they were getting from that process were actually fairly accurate. And that was all done just with trigonometry. So if your kids are saying they hate trigonometry and they don't want to learn it, well, you can tell them that it actually can be used for something. So let's go for a little stroll. I think I have, what, about, my session is finished when? At 4 o'clock, correct?
No, Jim, you're going till 4:15.
4:15, okay, good. Okay, so we have time to go for a little stroll, starting at the North Pole of the moon and making our way south. So the North Polar region is a quite old part of the moon. It's a highland region with a lot of very old craters and not many lava-filled plains. And as we move south along the Terminator, we get to an interesting feature called the Alpine Valley. I'll just type in some labels here for people.
Jim, while you're looking there, someone's asked a question
Sure.
relating to your current view. What is the rectangular patch?
In this particular view now?
I think it was just as you were talking about the Terminator, just as you moved into that first view. We were talking about doing the trigonometry stuff. That's.
I don't recall. That was further south from where I am now.
Okay.
Maybe if the person sees it again as we're moving south, they can point it out again. And I can try to answer the question. Well, this is a curious feature. It's a valley, but the valley seems to cut right through the middle of a mountain range. The range is called the Alps. The mountains on the moon have been given names of mountain ranges on the Earth. Just if you're wondering. Now, if we had really good seeing conditions, and we were able to get really high magnification, we would see that in the floor of this valley, there's actually an even smaller valley. It's kind of a squiggly line like this. That squiggly line goes out a little bit into the mare that's north of it. And so this squiggly line, squiggly valley on the floor of the Alpine Valley kind of gives away how this valley was probably formed. If we think that it's probably not due to stretching or movement of the crust, but by something going on underneath. And if Simon was on, he could talk our ear off about dikes. And that's lava that has pushed up underneath and then has receded.
Jim, we have a few more questions for you.
Sure.
Okay, is north of the moon just to match the Earth, or is there a regular magnetic field around the moon?
No, it's purely for our own convenience. So north on the moon is north from our perspective of the Earth as well.
Okay. Some craters look like volcanoes, but am I right that those do not exist on the moon?
That is actually incorrect. There are volcanoes on the moon. I don't think this time of this particular phase, I don't think we can see any moons. Let me just take a quick look here. Actually, there are some down here. There. Those little dimples right there are believed to be volcanoes.
Okay.
Not very exciting, but there are actually more impressive examples of volcanoes on the moon.
Okay, and the last question is, are you using any moon filters in your telescope for an image like this?
I am using actually an infrared filter. So this image that we see is only infrared light. And the reason that I do that is to get around the problems with seeing. The way that the Earth's atmosphere refracts light, it varies depending on the wavelength of the light. The longer the wavelength, the less affected the light is by the Earth's atmosphere. So by looking only at the infrared, I'm trying to get around the seeing as much as I can. That's how I achieve images as sharp as this from my backyard in central Ottawa.
Okay, thank you.
So a couple other interesting features before we move further south. One of my favorite craters it always makes me smile when I see it is the crater Cassini. And I say it makes me smile because to me, it looks like a happy face. Two eyes and a nose and a mouth. And that is purely coincidental alignment of craters, but it is pleasing to observe nonetheless. Okay, before we move too far south, the large crater up here is worth looking at because it shows some features that are quite typical of impact craters. And that's this crater up here, which is called Aristoteles. The names of the craters on the moon are all the names of scientific figures from the past who have had some association with astronomy. So Aristoteles, he would have been an ancient Greek philosopher. So this crater, as I said, is fairly typical. If you look in the center, the floor is fairly flat in the middle, but it has some bumps right in the middle, a central uplift, we would call it. Otherwise, the floor is flat. And then there are what we call terraces as you go out to the rim of the crater. And I'll try to draw a cross-section of a typical crater. Okay, so this is exaggerated in vertical height, but it gives you an idea of what the cross-section of the crater looks like. So the central uplift would be this part in the middle. And it's believed to be a result of the rebound of the moon's crust after the impact. The flat floor tends to be smooth because when the crater formed, it was covered in molten material. So the energy of the impact would have melted the rock. And when it was liquid, it formed a pond, relatively smooth before it hardened. And then on the inside of the rim, we see these terraces, and they don't form at exactly the moment of the impact, but they form shortly after. And they're a result of the rim of the crater not being able to support its own weight, and the material tends to slide, sort of landslide down into the crater after the impact has happened. And it tends to do it in these blocks to give the terraced look. On the outside of the crater, you'll see that there's a region where the moon has sort of a dimpled texture. And that's called the apron of the crater. And it's actually, it looks like that because of the debris that was splashed out of the impact. So a lot of melted material would have fallen in that area during the impact to give it that appearance. And then you may also see, let me move the crater label out of the way because you can see it better up at the top. There's strange streaks up here in the upper left from the crater, and that's due to large boulders being ejected from the impact and causing those marks in the surrounding landscape. So those are features that you can see around a lot of the larger impacts.
So Jim, we have a couple more questions for you.
Sure.
First one is, do you use infrared for lots of observations, and how is light pollution from your backyard?
Well, the light pollution from my backyard is terrible. On a typical good clear night, I can see about maybe a half a dozen stars. That's it, naked eye. So I observe, well, all of my observing is done with a camera. I do what's called electronically assisted astronomy. So I sit in my basement and the telescope's outside with a camera in it, and I always use a filter of some sort, whether it's an infrared pass filter or a filter design especially for looking at nebulae or other objects. I'm always using something to cut through the light pollution.
Okay.
And
Sorry, go ahead.
That was a two-part question. What was the?
There's a second question. Yes. Can you show an example of the youngest crater and where it is on the moon?
The youngest crater.
Probably Tycho, maybe. It's one of the earlier ones, or one of the new
I
ones.
don't think we can see Tycho in this phase.
No.
Let me go to the full frame again. The youngest crater, or one of the youngest, on this side of the moon. You can tell a crater is young by how bright it is. So this crater here called Proclus is one of the younger craters that we know of. And we know that because of how bright it is, how reflective it is. So that when there's a new impact, it tends to disturb the material on the moon to show fresh material underneath. And that makes it appear bright. It reflects sunlight better. And over time, the crater will slowly dull as it gets exposed to more solar rays and micrometeoroids, that sort of thing. So we know craters are younger by how bright they are. So Proclus, sorry, let me circle that. That's just this crater here. We know it's relatively young. But there's lots of other smaller craters like here and here. If it's brighter in appearance, then it's a younger crater. Exactly how young, we don't know. We don't have enough data collected from samples to know exactly how old those features are. But it's on the order of tens of millions to 100 million years, I think, on that order.
Okay, thank you.
Yeah, Tycho is relatively young, but it's, oh, actually you can see Tycho. There it is there. It's Sunrise Tycho crater in this image, but that's Tycho right there. And I believe it's, what do I think, it's 10 to 50 million, something like that.
Okay, then one of the questions just come in. Can you show us the Chandrayaan 2 crash site? Do you know where that is?
I don't know where that is, but
I think that was a, well, I think wasn't that supposed to be a polar,
yeah, I
Indian
think
polar one? Yeah.
I think so. Yeah, I'm
Yeah,
not
I don't
sure
know
where that is.
Yeah.
So let's go back to our marching down the Terminator here. So we were up here moving south. This is another very interesting area to explore. This is the Apennine Mountains. Again, just named after an Earth range. And we're starting to see some other interesting valley systems. So if you see, there's some valleys there. There's some valleys here. And there's a number of different ways that these structures can form. One of them being what I was mentioning before with a volcanic dike. And the idea is that if you have lava that's trying to come up from underneath the crust, it may come up really close, but but doesn't make it all the way to the surface. And eventually the lava may cool and shrink. And when it shrinks, it can cause, and Simon can correct me, I believe that's what we would call a graben, where you get a block of the crust will drop to fill a space where the lava was. So if the lava retreats, it leaves a gap, and that gap causes a block of the crust to drop down. So that's how what is going on with many of these narrow linear features. So these are on the order of a couple kilometers across and maybe a 1 kilometer deep sort of magnitude size.
Jim, you got about a minute left.
Okay, well then I will quickly go to one of my favorite features to observe during a first quarter. I'm going to zoom up a little bit past 100% so we get a better look at it. So this is an interesting feature in that depending on how good your seeing conditions are, it can actually look differently. Most of the time it looks like just a normal valley, a normal rill system, but when the seeing is really good, you can actually see that, especially in this area, it's not really a single valley, but it's a series of small pits. I'll say small, but they're, you know, a kilometer across. See, in these areas here, it's actually a chain of pits. And so the thought is that this is actually a volcanic feature, that there was lava underneath of the crust that again subsided and left the graben, so the main valley structure, but then the lava must have been close enough to the surface that it actually caused a cave-in, so a collapse of the surface. And what we're seeing are the little collapse pits along the chain. So that's it for now for me, I guess, unless there's any questions before I hand it over.
No, there's no further questions. Thank you very much.
All right, I will stop sharing. Thank you, everyone.